Hi. So this objective is 5.4, where we can apply something called trigonometry to find sides and angles in right triangles. So this lesson is really great because we're going to learn another strategy that can be used to find sides and angles in right triangles. So we'll start with our vocab. These words are going to be really important. Adjacent, which means next to. Hypotenuse, which is that side across from that 90-degree angle in a right triangle. Opposite means across. Ratio is when we say like 3 to 5 or 3 to 5. We're comparing two quantities, two or more, really. All right, and the new thing we're learning about is trig, which is basically just a study of relation between sides and angles in triangles. So we're going to learn about trig today. And then similar is when we've got the same shape. So remember, that means corresponding congruent angles, but a different size, which is basically when the sides are proportional, like abbreviating, but we'll go back to like 4.2 and 4.3 lessons for that stuff, okay? So let me kind of figure this out. I'm going to jump straight to the key points box, okay? So before we get into what trig really is, so when working with trigs, basically, we're talking about these, we're going to learn these three new words called sine, cosine, and tangent. Sine is abbreviated as SIN, cosine is abbreviated as COS, and tangent is abbreviated as TAN. So we very rarely write out the full words. We're going to use those symbols when we talk about the sine, cosine, or tangent of something. And basically, we find the sine, cosine, or tangent of an angle. So when working with trigonometry ratios, these are ratios of sides, we find the sine, cosine, tangent of an angle. In order to use these ratios, we must know which angle we are referring to, which is called the reference angle. So I'll make more sense in a second. Okay? And so basically what happens is, like, when we're looking at a right triangle, and if we pick a reference angle, so let's call beta our reference angle, so we're going to focus on this angle, and then what we're going to do is label our sides according to where they are in relationship to this reference angle, okay? So we'll notice that the side across from the 90-degree angle is always going to be the hypotenuse. The side across from the reference angle we're going to call opposite, and the side next to the reference angle we're going to call adjacent. And I'm abbreviating that as H, O, and A, okay? And so basically what will happen is, in this picture, the legs are going to be called opposite or adjacent, depending on which angle is the reference angle. The adjacent leg is the leg next to the reference angle. The opposite leg is the leg opposite. So just use the words adjacent and opposite. That'll make more sense why and later. And then something else that's new is like theta, which looks like that. It's a Greek letter commonly used to name angles. We might use other Greek letters like alpha and beta. Okay, but that's all we're learning in this key points is, like, we're going to start labeling our triangles with opposite, adjacent, and hypotenuse. Same thing here. We're going to label the sides if alpha is our reference angle. So now this is our reference angle. So the hypotenuse is still the hypotenuse, but now the opposite side is this side length, and the adjacent side length is this side length, because now we're using a different reference angle. Okay? So we're going to skip over light practice. We're going to skip over this kind of discovering thing. I'm going to jump straight to the key points box. It's going to be clear why are we labeling our sides with opposite, adjacent, and hypotenuse. That's because basically we're talking about something called trig ratios right now. where trig ratios, we're going to use the word sine, cosine, and tangent of an angle. So remember, this is our reference angle. Where basically we call the sine of the reference angle, that is equal to dividing the side opposite the reference angle by the hypotenuse of the right triangle. The cosine of an angle is equal to dividing the side adjacent that angle by the hypotenuse of the triangle. The tangent of theta, or a reference angle, is when we divide the side opposite the reference angle by the side adjacent to the reference angle. Okay? So, what I mean by this is if I'm asked to find the sine, cosine, and tangent of, in this case, alpha is our reference angle here. So, I'm going to code to make sure I'm I'm computing the ratios using the right numbers and the right sides. I'm going to code my sides opposite, adjacent, hypotenuse to my reference angle. So, hypotenuse is here, opposite, adjacent. Okay? So take that down. I'm going to be back in 1 second. Enjoy this penguin while I'm back. So, if I don't hear that change, okay, I'm back. So to find the sine, that's when I divide the opposite by the hypotenuse. So the sine of alpha is equal to O over H, which in this case is going to be equal to 8 over 17. Okay? So that's the sine. Cosine of alpha is equal to adjacent over hypotenuse, which in this case is going to be 15 over 17. Okay? And then tangent of theta, I'll write it up here, of alpha, is equal to opposite over adjacent. Right? And so I'm going to do opposite is 8, adjacent is 15. So if you're ever asked to, that's us computing what these values would be by hand. Okay? Let's do this example quick. So same idea, we're going to find the sine, cosine, and tangent of theta. So our reference angle is here. So we're going to do our 3 ratios. Something I will say is the phrase SOHCAHTOA can help us remember which sides go with which trig ratio. Okay? Now I'm noticing, okay, so I'm going to label opposite. My reference angle is here. Oh, here's my hypotenuse. This is my side adjacent to the reference angle. So sine, I need opposite over hypotenuse. So sine of theta is going to equal 6 over 10, which reduces to 3/5. Now cosine of theta, I need adjacent over hypotenuse. Now I don't have the adjacent, but now I can start using some of my other stuff I know about right triangles. I can do a squared plus b squared equals c squared. I can also notice this is the Pythagorean triple, 3, 4, 5. It's the doubled version of 3, 4, 5. So this is going to be 8. So cosine of theta is going to be equal to 8 over 10, which is 4/5. And then tangent of theta is going to be equal to opposite over adjacent, which is 6 over 8, which is equal to 3/4. Okay, so that's me. What we just did in this key points box is defining what the words sine, cosine, and tangent of an angle mean. What we're going to do next, and you'll get more practice doing that in the medium practice, what we're going to do next is start using the trig ratios to now write equations to find missing sides and angles. So, for example, if I have this situation here, where I've got a triangle and I know an angle, so this is going to be my reference angle because it's given to me, and let's say I want to find y. Alright, well let's label. This is hypotenuse, that's opposite, that's adjacent. Now what I'm noticing is that I want the adjacent side to the reference angle, and I'm given the hypotenuse. So that means if I think back to my SOHCAHTOA and I think of ka, because adjacent and hypotenuse, I'm ignoring the opposite side because we don't know what it is. That's not what I'm trying to find. But basically I can use this trig ratio to set up an equation. I can be like, okay, cosine of theta is equal to adjacent over hypotenuse, right? So cosine of 51 is then equal to y over 9. So now I have a setup of an equation. I can solve this equation. We'll get into how to solve it in a second. Right now I'm just setting up the equation. So what we're doing right here is to solve for a missing side or angle, you just decide which trig ratio. And when I say trig ratio, I mean the SOHCAHTOA pattern. Okay? So using SOHCAHTOA to write an equation. Decide which trig ratio to use based on what information is given or you're trying to find, and then write an equation. All right, so we'll do B together quick. So B, look, I'm noticing reference angle is here. So that's opposite. C is my hypotenuse. That's going to be my adjacent side then. So I'm noticing opposite is what I'm given. Hypotenuse is what I'm trying to find. So that's which trig ratio uses the opposite and the hypotenuse? Sine does. I'm noticing, oh, that's so. So sine of theta is equal to what? Opposite over hypotenuse. So now let's just plug it in. Sine of 39 is equal to opposite, which is 6. Hypotenuse is our C value. Okay? I'm going to do C now. C is, I'm noticing, oh, now I'm trying to find an angle. Okay? But let's still code this. This is opposite, and that's hypotenuse, right? Actually, I'm not going to do C. We'll go back to C in a minute. We're going to do D. Okay? So this is, oh, I'm trying to find an angle. But let's still call my sides. That's opposite, that's adjacent, right? So these are the two sides that are relevant. So O over A, that's tangent. If I need to think tangent of theta is equal to opposite over adjacent, I'm going to use that setup. Well, in this case, tangent of x is my variable, is equal to 4 over 8. And that would be my equation. Okay? So that's how to set up the equations. I'm going to let you do C on your own. So now we're going to jump to example 6, where now we're going to actually find the length of the side indicated by x. So I'm going to do my thoughts to set up my equation. I'm labeling hypotenuse. My reference angle is here. That side's opposite. That side must be adjacent. So what two sides do I care about? I'm trying to find x. I'm given the side opposite, so that's O over A, so that's tangent. So tangent is O over A, right? Or if I think like, you know, the TOA part. So now let's plug in. Tangent of 58 is equal to my opposite side, which is 22. My adjacent side is x, okay? So now, how do I solve this? All right. Notice, it's the same steps you'd use to solve for x. Please notice though that when I write down tangent of 58, what I'm doing is, like, these are your sine, cosine, and tangent buttons. So your calculator can do sine, cosine, and tangent for you of an angle. So when I write down tangent of 58, I really mean 1.600334529 la 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 la. But I'm not gonna like write this down. I'm just gonna write that value as tangent of 58. And I'm gonna, every time I like am talking about this value, I'm gonna write down tangent of 58 instead of this decimal. All right, so back to how do I solve this? Well, I'm noticing x is in my denominator. Here's what I can do. This is a fraction and this isn't. So let me put that over 1, and now I'm gonna cross multiply. And do x times tangent of 58 equals 1 times 22 is 22. Okay. Now to solve, I'm trying to get x by itself, so think, it's being multiplied by something, so let me divide by that something. Okay, and that's going to get me x. So x is going to equal 22 divided by whatever the tangent of 58 is. Now this is my exact answer. You can leave your answer exact. You can also, if it's more useful, I think you should like see it both ways. I can also just punch in my calculator. 22 divided by whatever the tangent of 58 was. It's capturing that big value. So it becomes 13.7. That's about how long x would be. Okay? We're going to actually skip over example 7, and I'm going to show you number 16 in your heavy practice. Quick, okay? So when I go here, finding the missing side, round to the nearest hundredth, okay? Cool. So I'm going to do the thing where I code. Hypotenuse, opposite. I'm noticing immediately that O and H are relevant. When I think of SO, CA, TOA, I'm going to use the SO setup. So I'm going to say sine of 22 is equal to opposite, which is R, hypotenuse with a 6, right? That was O over A. Now, this one's a little easier to solve because the variable is in the numerator, not the denominator. So what I can do is like, think about how you solve equations, right? You're trying to get x by itself, or the variable by itself. The variable is being divided by 6. How do I do that? Multiply by 6. So my exact answer is 6 times the sine of 22. That's R. Now, because the directions ask for the nearest hundredth, so I'm just going to put my calculator 6, sine of 22, and nearest hundredth, it looks like R becomes 2.25. Okay? All right. One last example. Now we're going to go be example 8 here. So we're finding the measure of the angle indicated by the question mark. So now we're solving for an angle. So again, all the same steps apply. Let me do my hypotenuse. This is my reference angle. That's opposite. That's adjacent, right? And so now I'm noticing, okay, adjacent hypotenuse is my CA. So I'm going to set up cosine of theta is equal again to my adjacent over hypotenuse. If you want to skip this step because you forgot in your brain, that's fine. Just trying to be over clear. So now cosine of x, let's call that x, that's we're solving for the angle. So now my variable is my angle. That's equal to 39 over 42. Now you might be thinking, how do I solve this equation? Now to get x by itself, we basically have to undo cosine. So some key points you got to know is if you're solving an equation, if you're trying to find the angle, use the inverse of the, please add the word trig ratio. So basically we're just using the, and your calculator will do it for you. So basically we call the inverse of trig ratios, we call them arc sine, and they look like this with a little -1. Okay, our arc cosine looks like that. Arc tangent looks like that. Okay? And basically, if you look at your calculator, they're the buttons that, like, if you look at your sine, cosine, and tangent buttons, do you see the ones that have the little -1? If I hit second first, my calculator is going to do the inverse of sine, cosine, or tangent now. Okay? So, back here, how do I solve this equation? I'm going to do, basically take the inverse of both sides. And that's going to cancel out cosine. Okay? And so, x is going to be equal to, and then I gotta do this to the other side, right? So cosine, arc cosine of 39 over 42. Now again, that's the exact answer. We could also throw it in our calculator. So I want to get arc cosine, not cosine. So notice if I hit this button, that's cosine, that's not arc cosine. I gotta hit second, then my cosine button, and now the little cosine shows up with a -1. And then just punch in, what was it, 39 over 42? 21 point, let's say 8 degrees is how much x is. Okay? That was a lot. Hope you follow. You got this. Have a good rest of your day.